Unit 4, Day 4. Now that we know how to find the mean and the standard deviation of a random variable, we would also like to know how to find the mean and the standard deviation of a function of a random variable. So let's go back to a problem from Unit 1, which was the cost of a taxi cab ride. If x is a random variable that's the length of the taxi cab ride in miles, that's a continuous random variable, okay? We can suppose that the average ride is 5.2 miles with a standard deviation or variance, with a standard deviation of 2.8 miles. Two taxi companies have different fare schedules. Company 1 charges $2.50 per mile, so that's this formula, 250 times the number of miles. And Company 2 charges $2 per mile plus an initial fee of $5. So basically you get in the taxi, shut the door, that's a $5 flag drop, and then they charge you $2 a mile. So thus, if we are interested in the total fare of a taxi ride Y, the two functions are as below. And that is what we did in Unit 1. Go back and look at your notes. And the question arises, how can we find the mean and standard deviation of Y for each case? Well, what we're going to do is we're going to use a linear transformation. And these are our formulas. Okay. We were trying to find the center, which would be the mean of Y, and we're also trying to find the spread, which would be the standard deviation. And I'm just going to leave those there for a minute and show you how to use them. Before that, let's recall from Chapter 6 that adding a constant to every value in a data set changes the measure of positions, mean, median, min, max, Q1, Q3, etc., but not the measures of spread. So if we had some data, okay, here's our center, and we added maybe where this is 0, this is 1, 2, 3, 4, this is 5. If we added 3 to everything, everything would just shift up by 3. Okay, so if you add a constant, it all shifts up by 3, but notice the spread is the same. Okay, so everything shifts by 3, but not the spread, which would be measured by standard deviation, range, and IQR, just moves up by 3. However, if you multiplied every value, the whole thing gets multiplied, and everything is going to change. Okay, so that's where these formulas up here come from, and that's what we're going to remember as we do all of this. So, however, multiplying every value in a data set by a constant changes both the measure of positions and the measure of spread. So, again, when we're just adding or subtracting, we change everything but the measures of spread. So we don't add and subtract onto standard deviation, range, and IQR. If we're multiplying, though, we change everything. So here's our thought. We're going to go to Company 1. So we want the average for Company 1, and Company 1 is $2.50 times the average, or times the miles per ride. And the average miles per ride was 5.2, so 2.5 times 5.2, and we get an average ride of $13. For our standard deviation again, well, that's just 250 times the average standard deviation, 2.5 times 2.8, that's the average standard deviation in miles. And we get an average standard deviation, we get a standard deviation for Company 1 of 7 miles. For Company 2, this is where we have to be a little more careful. When we're doing the mean, okay, the mean we're going to start at 5 and do 2 times the average number of miles in a ride, and we get 1540. Okay. However, we are just multiplying and we're doing standard deviation, so we don't need the 5 this time. That's what we were talking about before. Remember, we just multiply when we're doing standard deviations. So for the standard deviation of Company 2, we ignore the ride, and it's just the 2 times the number of miles, and it's the standard deviation of the number of miles, so 2.8, which means for Company 2, their standard deviation is 560. So what that means is that for Company 1, They have an average trip cost of $13 with a standard deviation of 7. So they're a little cheaper, but their rides tend to vary a little more. While for company 2, they're a little more expensive. On average, their trips cost $15.40 if you want the average number of miles, but they have more variation. Okay. So we're not done yet though, because getting in a taxi is just not the number of miles. You also have to tip the driver. So in addition to paying the fare, the passenger usually gives the driver a tip T. We're going to assume that the average tip is $1.50 with a standard deviation of 70, and that the tip does not depend on the fare. Usually you tip based off of how long you've been in the cab, but that's a lot harder to do, and these formulas don't always work with that, so we're going to assume that it doesn't. You were going to tip whatever you were going to tip no matter what. Okay, maybe just how much you liked your driver. It doesn't matter how long you were in the car. Let's think of what that means. The new total cost of each trip then is the fare plus the tip amount. So I need to add fares were given by the functions y plus the tip. What we're doing here is combining two random variables. The first random variable was the fares. Okay, it was these y's here. And we were able to figure out the mean and the standard deviation for both random variable y1 and y2. But now we also have a random variable t, which is the tip, that has a mean of 150 and a standard deviation of 70. So we need some formulas on how to find the mean and the standard deviation of a combination of two or more random variables. Here's the first formula. If x and y are random variables with the means mean of x and mean of y, and standard deviation x, and standard deviation of y, basically, if we were going to add the two, like we did here with the tips, where we're taking the fare plus the tip, we would just add the means. If we were going to subtract the two, maybe it's the fare, but then depending on how much you dislike the driver, you take money out of what you would pay him. Well, that would never work, but you were subtracting. So something where you would subtract, you just go ahead and subtract the means to find the new mean for the combination. Note, the mean formulas work regardless of whether x and y are independent. Don't worry about that, okay? Now we need to look at the variances though, or the standard deviation. Remember, variance is just the standard deviation squared, and we're going to talk about variance here because these formulas are dependent on us squaring the values. And these only work when x or y are independent. So in this case, x and y would be y and t, and that would mean that how much you tip depends on how much you pay. And it wouldn't work if that was the case. Okay, so the standard deviation formulas would not work if the how much you tip depends on how much you pay. And the reason we have to use the squared values is because of, if we square them, the variance plus the next variance equals the two added up. But if you just use the standard deviations, they don't always equal. It's the idea of, remember the Pythagorean theorem, a squared plus b squared equals c squared? That does not mean the a plus b equals c. Okay, that's not always true. So for this next formula, or I guess for this formula up here, which I kind of skipped over, we're going to use the squares. So I kind of skipped over this formula. I didn't realize I thought I was going to write it for you. Basically, if you're doing the means, if you're adding, you add them. If you're subtracting, you're subtracting. But if you're doing the standard deviations, whether you're adding or subtracting, you end up adding the variances. So if you're going to do it with variances, it looks like this. If you're going to do it with standard deviations, then you have to square root. But everything in it has to be a variance, and this was why. Okay, let's talk about that idea of always adding, whether you're adding or subtracting. Note, even when you're subtracting the random variables, we add their variances. More variables always mean more variability. So let's say here's an example of subtraction 1, the amount of ice cream. So we have some chocolate ice cream here, and it varies. You don't know if your mom or brothers or sisters have been in the chocolate ice cream. You don't know how much is in there when you open it. And you also know you have several scoops in the cupboard or in the drawer. and the size of the scoop varies. You just grab one. So our new random variable, our combination, would be the amount of ice cream minus the amount that we could take out with one scoop. Okay, and the new random variable will be the amount that's left in the container. Well, if you think about that, every time you open it up to check, you don't know how much is in the container, and then the fact that you're subtracting from it a varying amount of ice cream, because you don't know which scoop you have, means that you're adding more variability. So your standard deviation needs to go up. So whether you're adding or subtracting, you always add in your formula. So here's your mean formula, and here's your standard deviation formula that I didn't mean to skip over. All right, so lastly, let's try this with the two companies. So for company 1, the average ride was $13 with the standard deviation of 7. So if we wanted to find the mean when you include the tip, okay, that's the average ride plus the average tip amount. And now for company 1, the average cost of a ride is $14.50. For company 1, their standard deviation was 7. Okay, now, wait, let's go back and use the formula. Let's look at the formula. Here's the formula. We're going to use this version right here. It says take the square root of the two different standard deviations squared. So we have the square root. The standard deviation for company 1 was 7. And the standard deviation for the tip was 70 cents. Which will give us about, it gives us 7035, so about $7.04. So it's just plugging into the formula. Now let's do it for company 2. For company 2, the average cost of a ride was $15.40 with a standard deviation of $5.60. So if we want to find the total cost, including the tip, we would take the average cost of company 2's ride plus the average cost of a tip, which is $1.50. And now the total average cost of company 2 is $16.90. And then again, for standard deviation, we're going to use that square root formula. And so we take the variances, or the standard deviation squared. The standard deviation for company 2 was 560. We square it, plus the standard deviation of the tip, which was 70 cents. And we square it. And that was the wrong color green. Oops. Again, square root. And you take standard deviation squared, or variance, plus standard deviation squared. The other word for that is variance. And we have a new combined standard deviation of $5.64. So a total trip, including the tip. That's what we found here. So for company 1, the total cost of your trip, including the tip, on average is $14.50 with a standard deviation of 704. While for company 2, the total cost of your ride on average is $16.90 with a standard deviation of $5.64. That's including the tip. So again, we're just learning how to use the formulas. The first formula being this one right here. Okay, and the second formula being the one I kind of skipped over, these two. And you can use either one. I used this one back here. Basically said if we needed to add two random variables, we add their standard deviations squared and then square root it to get the standard deviation. But also if we needed to subtract them, we would still add them, because adding and subtracting adds more variability. The rest of this we will do in class to clear up any questions.